Azure Data Explorer is a mature, fun, convenient, and accessible service with a bombastic amount of data and users.
Hi everyone, and welcome to Azure Data Explorer virtual event. My name is Oded Sacher. I'm Cousteau Group Manager, which is the amazing team behind Azure Data Explorer.
And I'm Uri Barash. I'm the Group Program Manager for Azure Data Explorer Cousteau, and it's a pleasure to be here today.
A few years ago, together with 3 friends, we founded Cousteau Incubation Project, aiming to disrupt the way engineers at Microsoft are exploring telemetry data and derive meaningful insights from their business. The service spread like wildfire and changed the way digital transformation is practiced every day across all Microsoft. Since the public preview of Azure Data Explorer 2 years ago, we've seen great adoption of many Azure top customers in a variety of industries and scenarios. Today, we invite you to take some time and learn about the vision, roadmap, and what's coming next. We have exciting announcements of new extreme analytics power, cool features, and partnerships that open up additional scenarios. We will have Rohan, Kumar, Azure Data Corporate VP, customer testimonies, and engineers from the product groups all on the same virtual stage to make the best out of your time. At the breakout sessions, you'll have the opportunity to go deeper into different topics and have interactive discussion with our product group engineers. Enjoy the rest of the day.
Thank you, Oded. So let's drill a little bit into what is Azure Data Explorer and how does it help us achieve our goals. We are talking about a high velocity business environment. Things are moving very, very quickly, changing and adjusting. And data that we used to have in computer systems is growing and growing and growing. And it's growing not only in volume, but also in the diversity. We have applications that change constantly. We have new versions. We have new versions of devices. We have vendors that change regularly, and things evolve. And instead of changing the way we collect information about the activity that's going on around us, instead of changing the data pipelines that we're using in order to collect this information, a lot of engineers are just putting the data and coding it in text fields, in JSON, semi-structured content, which makes the data a lot more complex. The agility of the business environment is so high that we don't know what are the questions that we need to answer tomorrow. And therefore, we are just collecting the data. We're not even aggregating as it comes in, because very soon we'll need to answer questions that we didn't plan that will need to answer. And those decisions are actually coming in also an accelerating rate. And in order to answer those business decisions, we need more and more people that can make data-driven decisions and deal with those business challenges that arrive at our doorstep. And this is practically the essence of the digital transformation, the ability for every organization to sense every activity, everything that happens around it and can impact its business success. This is why we introduced Azure Data Explorer, which is a big data interactive analytics data platform for telemetry that is fully managed for efficiency, optimized for high velocity data that's streaming in, and designed for data exploration. When we're looking at what the service actually is, we're talking about an append-only data platform that's optimized for big data, high volume, high velocity, high variance. And with high variance, I mean full text, structured data, and semi-structured data like JSON. And all this is available with all what you can expect from a database: columns, rows, tables, the ability to filter, sort, join, and even run time series analysis, full text search, and even run Python and R embedded inline in the query language to provide the extreme extensibility. All as a fully managed service in the cloud in a domain agnostic way that's optimized for this workload, specifically for big data analytics and for interactivity. We'll switch to a demo showing how we can analyze GitHub activity data over a huge data set. And here we're looking at a database of GitHub operations, users interacting with GitHub, and we have 1.2 billion records in this data set. And those actions span 3 years, between 2016 to 2019. You can see that those are like 1.2 billion records, but it doesn't help us to understand if the data is full within those extreme dates. So we'll aggregate the data by bins of 1 day and see how many operations are there per day over this period. And we can see that the data is fairly complete, and we can see the weekends, we can see the holiday seasons. And if we're looking at how the data is structured in the database, we can see that there are like simple columns like the ID and the date, but there are also highly complex columns in JSON format that could have different schema for each row separately. With Azure Data Explorer, we can actually query natively into those JSON semi-structured fields. For example, here we're looking at 10 contributors into the GitHub data. Display login is the unique identifier for a user. And now comes the question, like how many different people contributed to GitHub in this 3-year period? In order to answer that, we'll run a distinct count over the display login field within the JSON record and see how many unique contributors have contributed to GitHub in this period. And we see that 16 million people interacted with GitHub. This practically means cranking open 1.2 billion JSON records, and that query ran for 1.4 seconds. Now that's fast. Azure Data Explorer, as Vlad said, launched externally 2 years ago, but it's been in production at Microsoft for the last 6 years. And at Microsoft, it's the facto standard for powering analytical solutions as a service. And we're talking about monitoring solutions as a service with Azure Monitor and Log Analytics and Application Insights and Intunes. We're talking about all the security products from Microsoft, threat hunting, security investigation, everything is powered by Azure Data Explorer. The IoT platform at Microsoft is all powered by Azure Data Explorer for all the IoT telemetry. And we're talking about gaming and education and retail with PlayFab and Teams Education and Bing analytical solutions for retail. And currently we're hosting more than 60% of the Azure top customers are actually running on Azure Data Explorer. And as part of that, we are seeing 3 main scenarios. The first scenario is that enterprises want to create a unified platform for telemetry across all their usages, from the web usage, IoT devices, application logs, what have you, all in the same place, all correlatable, enabling digital transformation. We are also seeing companies, ISVs and services that leverage the same capability in order to provide vertical solutions to help organizations in exactly the same challenge by providing analytical solutions as a service in similar domains. For example, Bühler, that is building food processing machines, pasta, chocolate making machine that are providing analytical solutions for their customers on how their machines are behaving. Financial Fabrics is doing this in the financial industries environment, Siemens in health, etc. And the third scenario is that companies are leveraging Azure Data Explorer to go one step beyond and run AI, ML on the data as it comes in real time, providing a lot more flexibility for applying machine learning and AI models on data. And this is just a small sample of the incredible list of customers and partners that we work with on a daily basis.
Thank you very much, Henri. And what's next?
So take a look at the agenda. We have a wonderful few hours in front of us. And with that, I'd like to invite Rohan Kumar, the Corporate Vice President for Azure Data, to the stage. Welcome, Rohan.
Thank you all for joining me today. My name is Rohan Kumar, and I lead the Azure Data Group at Microsoft. I'm really excited to take part in today's event and share some of the innovations the team has been working on and to talk about our focus on telemetry analytics. In our experience with working with several thousand customers, digital transformation boils down to these four scenarios. Every customer we speak to wants to build a data-driven culture. They want to empower their employees with the tools that enable them to be the best in their roles. Use the intelligence from their data, customer feedback through digital connected experiences to build better products, innovate on business models, and significantly improve efficiency to save on operational costs. A modern data and AI platform is at the center of it all. This huge influx of data that's powering AI opportunities is not only enabled by the shift to the intelligent cloud, but we are also seeing a foundational shift in the computing paradigm to the intelligent edge. The intelligent edge enables you to package your applications into containers and deploy them onto the devices themselves, delivering intelligence to where the action is happening. So why is the intelligent edge important? Today, everything around us is being digitized. We expect 50 billion IoT devices by 2030, and many of these devices will have limited processing power and sporadic connectivity. Most of the data will be stored on these edge devices and will require real-time analytics. With the intelligent edge, you can enable a variety of devices to make intelligent decisions which will be critical to the modern applications. One of the key types of data that's really critical and very high volume in this new application paradigm is telemetry. Telemetry data is everywhere. We find it in IoT sensors, logs, clickstreams. It drives advances in connected devices we find in our homes, smart buildings, smart factories, and in devices that consumers and businesses rely on. Telemetry data is clearly fueling digital transformation. It is generating petabytes of data every day. Daimler Trucks North America is an automotive industry manufacturer of commercial vehicles. They're using Azure Data Explorer to power their digital transformation journey by building solutions around connected trucks and connected factories. Let's hear the story from Lutz Beck, CIO at Daimler Trucks North America and members of his team.
Thank you, Rohan, for introducing me. My name is Lutz Beck. I'm the CIO of Daimler Trucks North America. Daimler Trucks North America is since beginning of 2019 on its way to transform the organization and build the intelligent company. In the middle of the intelligent company, we're using data as the key asset to leverage across the whole value stream of the company. We are transforming product and services, processes and people And we use data to build our digital foundation and also leverage data in our key strategic building blocks, which are connected and electrified vehicles, autonomous and automated vehicles, customer experience, smart factories, data-driven in general, and also on the cybersecurity side. So data is for us in the midst of everything what we are doing. We generate also new services for our customers based on the data. And with ADX, we have now the right tool and the support as well to achieve our mission in building the intelligent company and a data-driven organization at Daimler Trucks North America. So I just told you how ADX is supporting our mission. So the Azure Data Explorer is really helping us in various ways. And my lead for the Data Intelligence Hub here at DTNA, Doug Murphy and Sammi Li will explain you how we are doing and how we are using the ADX.
Hi, I'm Doug Murphy. I lead the Data Intelligence Hub here at Daimler Trucks North America. For years, we have been collecting valuable data, but we're not able to get the full potential out of it. In Azure Data Explorer, we brought together data from our connected trucks, our connected factories, truck configurations, and quality and repair information to build an end-to-end timeline of the life of our products. This is enabling our team of engineers, data scientists, and analysts to gain new insights to the performance of our products out in the real world. In the trucking industry, vehicle uptime is one of the most important factors for our customers to be successful. We can now investigate vehicle performance at the macro level and identify component design improvements that make our vehicles more reliable. At the same time, we can now use machine learning to find signs of trouble with individual vehicles. We can zoom in close and soon be able to give our customers early warning of needed repairs before it causes a breakdown on the side of the road. Now you'll hear from one of our expert data analysts, Sammi Li.
My name is Sammi Li, and I'm a data analyst at Daimler Trucks North America. We are currently managing 9 trillion rows of data with a total original size of 938 terabytes in ADX. With many different efforts going on within DTNA, the challenge has been making the data available to each group without making multiple copies or extracts. For these large, sensitive datasets, this would not only increase costs, but risk losing control of the data. Azure Data Share has solved the problem for us, allowing us to maintain one instance, our single source of truth, then add decoupled compute clusters provisioned to just the data needed by each group. This avoids oversharing as well as competition for resources from other users accessing the same data. Now back to you, Rohan.
Thanks, Daimler team. Wow, these numbers are huge. 9 trillion rows and 900 plus terabytes of data. It's amazing to see the scale at which Daimler is using Azure Data Explorer to drive product design improvements and predictive maintenance. I'm excited to share that we're taking Azure Data Explorer to the next level, and I'm very excited to announce the V3 engine, accelerating innovations with improved text indexing and data encoding, query time code generation, and improved disk access. Comparing the current version of Azure Data Explorer, on an average, Azure Data Explorer's V3 engine is up to 113 times faster, has 30 times better concurrency, and is 30 to 50% cheaper with the new NVMe Access AMD SKUs. This is a game changer. Let's look at a demo from Oded Sasha, who leads the Azure Data Explorer engineering team, and see how his team uses their own product to manage its massive global service.
Thank you, Rohan. Let's have a taste of what Azure Data Explorer has to offer. Log analytics for troubleshooting and diagnostics is probably the sweetest spot of ADX. And this short demo is about how we, the Custod team, are leveraging ADX for that purpose. One of the operational routines we practice for identifying problems in production is called proactive maintenance. Engineers on proactive maintenance shift are digging through the service telemetry to find issues that are not triggering monitoring alerts, yet might get worse if we don't take the right measures. Does it sound like finding a needle in a haystack? Yes, But here comes ADX for rescue. We'll start the tour at ADX Dashboards. It is a dashboarding application currently in preview, which is purposely built to provide the best authoring and consumption experience over your data in ADX. This dashboard, which I created for my proactive maintenance shift, is driven by live production ADX service telemetry. Telemetry is collected in near real time from every ADX cluster and ingested into yet another ADX cluster running Engine v3. The cluster named Couscous, Cousteau and Cousteau, is the product team's main and critical resource for operating our service. I can examine the error traces rate by different dimensions. I can see how they spread over time, what are the hot regions, and the top 5 noisy clusters. Now let me change the time window and show you how it looked like when I started my shift a few days ago. The dashboard is now refreshing. And you can clearly see that around 7 a.m. there was something worth exploring in a single cluster at WestGS region. So far, it seems like a fairly standard operational dashboard. Well, not really. Let's start exploring and you will quickly understand why. The first big advantage of ADX dashboards is that the raw data is one click away. And exploring data with Cousteau query language is not only powerful but also great fun. It has built-in IntelliSense, a constantly growing list of powerful analytics operators, and most important, amazing query performance for ad hoc and interactive experience. Before we dive into the anomaly that surfaced in the dashboard, let's get some statistics over the data. We're talking about 100,000 Cousteau VMs running across all Azure regions that send traces to a single table, Cousteau logs, at an average rate of 10 million records per second and latency of 2 minutes. There are over 26 trillion records in the table, which are available for immediate query. Now take a moment to reflect on the proactive maintenance dashboard I've showed you that is built directly over this huge table of raw data. No complex ETLs, no professional modeling, no granularity loss due to pre-aggregations, nothing but queries over raw data waiting to be explored. And this is exactly what I'll do next. Using the reduce operator, I can quickly group a sample of error traces together based on error message similarity and observe a common trace error that is related to XML parsing. Now I want to understand what kind of client request triggered those XML parsing errors. This query applies time and text filters over trillions of records, and I managed to identify my immediate suspect in no time, this client request ID. And this request is indeed suspicious. A single client request generating 268 million trace records, most of them are errors. Using the parse operator, I created a new API calculated column from the usage trace and learned that the client request is an admin command. One last query to identify the specific type of admin command and my puzzle is mostly done. Looks like a client request to ingest data using set or replace admin command pushed 268 million strings of malformed XML and caused the engine to generate way too many error traces. From here, fixing the trace line in the code was straightforward and I was ready for my next investigation. To summarize, we're talking about 26 trillion records table with new fresh data flowing in a rate of 10 million records per second. I used Azure Data Explorer dashboards to build aggregated view over raw data. Then, with few ad hoc and interactive queries over the same data, I managed to pinpoint a specific set or place admin command that tried to ingest malformed XML and generated huge amount of parsing errors. You've seen the unique value of Azure Data Explorer in action, a rare combination of unlimited scale, near real-time ingestion, innovative query language, powerful analytics over heterogeneous data, and now, with our new engine V3, even more extreme performance. Back to you, Rohan.
Thanks, Oded. Wow. Data flowing at 10 million records per second, near real-time analytics on a table with 26 trillion records. Very impressive. This is the superpower of Azure Data Explorer. Next, let's look at an example of how our partners are leveraging Azure Data Explorer today to help protect their customers from fifth-generation cyber attacks. Check Point is a leading provider of cybersecurity solutions to governments and corporate enterprises globally. Let's hear from Itai Greenberg, who's the VP of Product Management and Product Marketing at Check Point.
Hi, my name is Itai Greenberg, and I'm the VP Product Management and Product Marketing in Check Point. Check Point is a market leader in cybersecurity. We have over 100,000 customers worldwide. Customers use Check Point to secure their data center, to secure their mobile device, to secure their endpoint and perimeter network, but definitely Check Point is used widely to secure customers' public clouds. For the last 2 years, Microsoft selected Check Point as the #1 security vendors for Microsoft Azure. We are a very strong partner of Microsoft when it comes to secure anything on the Azure infrastructure environment, when it comes to secure Microsoft Azure on the PaaS or the services they are running in Azure. We secure Azure on Office 365 and many more things that we do with Microsoft together. Over the last few years, we've seen customers moving to the cloud, obviously, and also Check Point customers want not only to secure the cloud environments, but also to manage the Check Point environments from the cloud. And we are offering our customers a service where they can aggregate, collect all the logs from all the products, from the data center products that we have, from the mobile endpoint, and from the clouds, all into a central logging location. And this logging location, we selected Check Point, the Check Point Data Explorer, as the place we want to host to service our customers with this unified, gigantic log service. So what are we offering to our customers? Customers can go now and analyze, understand how everything actually works together. So we collect billions of logs every day. We collect logs from traffic activities, whether it comes from our gateways, but definitely when it comes from the cloud itself, from the security that we apply in the cloud. We collect security events, we collect compliance events, audit events. Everything comes into one place. And this is our big data lake that we are offering our customers to consume from a central location. And this central location, again, is hosted on Microsoft Data Explorer in the cloud. So over the last several months, our R&D evaluated different cloud platforms to host this gigantic data lake. Actually, we're using right now a data lake on one of the cloud providers, but we decided to move it into Azure. We find the Azure Data Explorer to be very robust. R&D very enjoys to using with the APIs to move the data into this environment. And the most important thing is that the performance, the customer that will use these data lakes to run a very complex analytics will be able to achieve a very fast performance. And for us, for Check Point, we also find out that the cost effectiveness of this solution is very appealing, which eventually translates to our customers. So when you look at what Check Point customers are doing, they secure the Azure cloud environment. We provide the security for the containers, for the serverless functions, for all these thousands of applications that are running in the cloud. And as I mentioned, already we have over 4,000 enterprise customers that use us to secure the cloud. Thinking about the value that they can get by running all the logs, all the activities in a central locations and analyze it. Analyze it from a platform that not only see what's happening in the cloud, see what's happening for the entire organization. So if I'm a user that is accessing from my endpoint or from my mobile device into my data center, my cloud, I might get infected in one place or another. I want to see a full picture. I want to understand what is happening across all those use cases and attack vectors. Having all the logs, all this information stored, hosted in a unified location give a huge advantage to our customers. And having this partnership with Microsoft in developing these solutions together, in understanding how to build it in the right way, really helped us to provide this kind of service to our customers. So we are looking forward in the coming years to host teras, billions of data and logs and activities, and we selected the Azure Data Explorer to be the solution for us. Between Microsoft and Check Point, we have real partnership. We have a partnership on developing product together. For example, what we're doing together with Microsoft on the Data Explorer, but also on what we do currently with Microsoft as a design partners on the SD-WAN integration. We have a partnership with Microsoft to go to our mutual customers and help them to build their applications in the cloud in a secure way. So we are both committed to this partnership and see a lot of success together. And we are grateful to be selected by Microsoft as the #1 security vendors for Azure. Good luck and thank you very much.
For the last 25 years, we have set the standard for cybersecurity. Checkpoint. We secure your everything.
Thanks, Itai, for sharing your journey with Azure Data Explorer. It's amazing to see you bring in terabytes of logs to Azure Data Explorer to build security analytics solutions. We are truly looking forward to this partnership. We shared just 2 customer success stories today, and we are receiving a lot of great feedback from other customers about Azure Data Explorer, with customers eager to leverage it to do more with it. With that, I'm excited to announce Azure Data Explorer's data connector for Azure Synapse. Azure Cloud is the best platform to do your analytics at cloud scale. Azure Synapse Analytics brings together the worlds of enterprise data integration, data warehousing, and big data analytics into a single service, both through on-demand and serverless provisioned resources. We've been hearing from customers who leverage Azure Data Explorer and Synapse together and build rich analytical solutions. The Azure Data Explorer Data Connector for Azure Synapse will allow you to leverage the Spark engine and other Synapse capabilities from your workspace. This is only the beginning of this journey. Azure Data Explorer will be deeply integrated into Synapse as a native offering. Manoj Raheja from our team is here to share more in a short demo. Manoj, please take it away.
Hi there, I'm Manoj Raheja. I'm a product manager with Azure Data Explorer team. For this demo, let's imagine you're collecting a lot of telemetry data from your IoT sensors, devices, and so on, and you would like to generate alerts, reports, and query that data in near real time. So in Azure, you can use Azure Data Explorer to stream this data directly into Data Explorer, where the data is cached, indexed, and available for querying in near real time. And you can use your choice of visualization tools to go and access the data and then achieve your goal of creating alerts, reports, and query the data. In many situations, you may want to archive this data for long-term retention, for running batch jobs, for doing machine learning training, or doing data processing and merging the data with the rest of your big data platform and so on. For that, Azure Data Explorer offers a continuous export capability, which can constantly export out data into a Parquet format onto a data lake. And it can be partitioned and ready for consumption. Once you do that, you can easily link that data lake account with Synapse and then access that data from other capabilities into Synapse, like SQL on demand or Spark and other services in Synapse that you can use on top of that data. We're excited to announce a new connector that we have added in Azure Synapse, which is an extension of our Spark connector, which is pre-installed on Azure Spark instances, which allows you to read data from Azure Data Explorer as well as write data to Azure Data Explorer or stream data to Azure Data Explorer in a seamless manner and a secure manner. It supports AAD pass-through authentication, so you don't have to worry about authentication, which comes out of Synapse link services. Let's look at a quick demo now. I'm in Synapse workspace now. To get started, go and click the plus sign here and connect to external data. Select Azure Data Explorer, continue, fill in all the details to which cluster you want to connect to, which service principal you want to use it. Either you can provide service principal here or take it from Key Vault, specify the database, and make sure you test the connection and create it. Once you create the connection, it's going to show up here under Azure Data Explorer, and these are all the clusters that I've already connected. We're going to look at one of the demo clusters that we have here called Ignite ADX Source, which have a bunch of databases, so you can go and explore it here. We have added a seamless experience. Right from here, you can create Spark notebooks. So for example, this Spark notebook is for reading data. You can create another notebook for writing data to Azure Data Explorer or streaming data to Azure Data Explorer right from here. And you can see how simple it is. It just uses the format of the sync, and you're specifying the connection details, and that's it. And you can easily push your data frame into Azure Data Explorer. Let's look at one quick demo here. In this case, I'm going and reading data which is coming in near real time into my database, and I wanted to go and query the data that came in last 5 minutes window. So I've just specified my query here, thermostat, where the time is 5 minutes ago, and I'm going to run that. So you can see how integrated experience is this, where it will use the AAD pass-through authentication, get the data, and then display it here. This is a super simple example, but once the data is in data frame, pretty much you can use in any other context here. So this is a reading data. Let's switch gears here. Now you have a scenario where the data is constantly getting exported from Azure Data Explorer, and that's available in Data Lake, and you would like to go and do a batch processing of the data or create machine learning models and then push those models back into Azure Data Explorer for scoring on the near real-time data that's coming in. For that, here I'm just going and accessing data that's in the data lake. Again, this also uses AAD pass-through authentication that Synapse provide out of the box, and then going and running the aggregates here. And once the aggregate is there, I can simply push that data into Azure Data Explorer. For example, here I have my data frame, and I'm selecting a couple of columns that I wanted to push through, and just append, and the data in few minutes, the data will be available in Azure Data Explorer. This connector is been designed and tested for large data volume throughput, runs in a distributed fashion. And there are customers are doing a lot of creative stuff with this. I just showed you a very simple example to demonstrate the integration, and we are excited to see how you can leverage this service. Thank you, and back to you, Rohan.
Thanks, Manoj. It's great to see how Azure Data Explorer and Azure Synapse are integrating to cover the full spectrum of the analytic use cases. We are not stopping there. We are very excited to announce our partnership with AMD in supporting AMD EPYC processor SKUs to power big data workloads on Azure Data Explorer, and several other great product integrations and features you will learn about during this online event. We just saw how customers like Daimler are using Azure Data Explorer at scale for IoT analytics scenarios around connected trucks and connected factories. And we see partners like Checkpoint building security log analytics solutions on Azure Data Explorer. It is fantastic to share the innovation the team has built into the platform to offer you the best price performance for your telemetry workload. I look forward to seeing you leverage Azure Data Explorer and take advantage of Microsoft's internal learnings that help harden this service and ensure we execute on such massive scale. Thank you for joining me today to reimagine telemetry analytics. Enjoy the rest of the event.
constantly innovating and renewing, we have rewritten the whole engine of the service. There is a good smell in the air. Some numbers. "51 regions in Azure. Monthly direct users, 35,000. 35 petabytes ingested every day. 1,100,000 cores. 1 billion queries per day. 2,000 petabytes data size.
Hey, and welcome to What's New with Azure Data Explorer. My name is Tzvia Gitlin.
Hey Tzvia, and I'm Gabi.
And together we are Azure Data Explorer Program Managers. In the next 30 minutes we will share many new Azure Data Explorer features and collaborations. We will cover main 6 core areas in Azure Data Explorer. We will start with ingestion new capabilities. Then we will demo new features to query data in high performance and custom optimization. Gabi will share with you some new visualization features and enterprise ready. We will finish with collaborations and new compute availability. Are we ready to start?
Yes, let's get started.
Ingestion. Let's talk about some enhancement to bring data. FluentBit and Azure Data Explorer agreed on collaboration to bring new connector to ingest high volume of data in low cost. This is an open source project which already available in public preview to forward mass data into Azure Data and then to define event grid to collect the data into Azure Data Explorer. There are only 4 parameters you need to define, and the data will flow into storage account. And then, with one click or Azure Portal, you can define event grid to enable continuous ingestion to Azure Data Explorer cluster. Currently, FluentBit supports block blob and append blob, but only block blob is supported to ingest data with event grid to Azure Data Explorer. Let's see a short demo. So I've created in advance a Kubernetes service that now we will connect to it with our connector. So first, I'm going to a PowerShell and I will connect to my user. I'm using my account and now it will take a couple of seconds till it will connect and subscribe all the options that we have under my account. So now I am connecting to my user and now I would like to connect to my Kubernetes service. So I'm going to the Azure portal page and I'm copy the connection string and paste it into the PowerShell console and also provide me credential to run commands. Wonderful, now it's merged and I'm ready to create the connector of FluentBit that will forward the data from Kubernetes service, the telemetry data of Kubernetes service, into Azure Data Explorer. And in the middle, you will put it into Azure Storage. So first, I'm going to the setting page. The setting page, I need to define the storage account, the key, the type of the blob, block blob or append blob, and of course, the name of the container. I will save it. Okay, and I am ready to create the connector. Wonderful. Now the connector was created and in a couple of seconds, actually 5 seconds of latency, we will see the data starting to copy to the storage account. Let's go to my storage account. I will refresh the containers and you can see now that there is a new container called Azure Data Explorer event. This is a new container with new folders and data is getting in an ongoing process. So Gabi, what do you think about this new connector?
Looks exciting. Can't wait to start playing with it.
Wonderful. Ingestion is the first phase to every user to start his journey with Azure Data Explorer, actually with every data platform. So we define a goal to reduce the complexity and to create smooth user experience to bring terabytes of information in a couple of minutes. One-click is a set of capabilities to enable wizard-like experience to define the first ingestion infrastructure. One-click can infer a table schema based on your dataset and to enable you to make schema adjustment with intuitive user experience. With one-click, you can define tables, mapping, one-time and continuous ingestion from multiple sources and from any type of supported format. And soon, also ingestion from Event Hub with semi-automatic schema inference to define table per Event Hub events. One-click is now in general availability. How exciting it is!
Very exciting.
So let's see a short demo?
Yes, perfect.
So we have a storage account with information from the previous demo from FluentBit. As you can see, data is copied on and over from FluentBit connector. Now I will open Azure Data Explorer, the web version of our Explorer, and you can go there and to click on Ingest New Data. You can also have the option to create table and also to ingest new data. You can see here the preview, but actually it's in J. Once the wizard is opening, you can define where do you want to create the table, whether it's in this database or any other database under this cluster. You can define to ingest the data to existing table or to create a new table. I will create a new table. Next to do is to define the source. You can ingest data from one blob, from a local file, and also from container with up to 10,000 blob. Here you need to go and copy the SAS URL of your container. I'm open the storage account from the previous demo and I click on Get Shared Access Signature. I just need a read access for that and I am copy the SAS URL. I'm taking it and I'm copy it into the link to storage and move to the next field. Now the service access to this storage and run an inference to define the schema of the data. And I'm moving to the next schema. Based on the suffix of the file, the service identified the format of the information. Here it was identified wrongly to CSV, but I can easily change it to JSON. And now I have a JSON format and I can change how nested I would like the data to be. Here I have one dynamic column with nested JSON inside, but I can change here the JSON level to be 2 and you can see that the data is spread all around and you can use it as a structure table. By clicking on Start Ingestion, the new table and mapping will be created and you can see it over here. And data that currently we have 371 blob will be ingested into the service and you can see the status of those blobs over here. And here you can see some preview of the data and just to verify that the data was ingested as you wanted it to be. But this is one-time ingestion, and if the data is important for you and you would like to ingest all the ongoing data that will be copied by FluentBit connector, you need to go to Continuous Ingestion, click on Event Grid. The service will open Azure portal page with predefined resources that will be defined automatically by the service. You can see here the service will create Event Grid subscription on this storage account with Event Hub and Consumer Group, and by clicking on the Create button, we will define Event Grid, an agent that will listen to this container, and whenever the new data will be copied to this container, they automatically will be ingested into this table.
Looks very nice. It gives you a lot of capabilities. I'm looking forward to try it out also. Yeah.
Thank you. Azure Data Explorer Kafka connector is available for more than 2 years, but in the last couple of months we invested time to increase quality, stability, and also to get gold certification from Confluent. So now Azure Data Explorer Kafka connector is gold certified by Confluent and can be used to ingest data into Azure Data Explorer at scale from Apache Kafka cluster. With streaming ingestion, I will start with the bottom line. Streaming ingestion is now available in general availability. Whenever there are requirements to ingest small amount of data per table with seconds of latency, streaming ingestion is the solution for that. By default, batching ingestion is the optimized ingestion pipeline for Azure Data Explorer, with default batching settings of 5 minutes, 500 items, or 1000 megabytes of data, the first one from the list. But in cases you need a near real-time response time from ingestion to query, and you have many tables and few records per table, streaming ingestion is the solution for that. One of Azure Data Explorer magic is the ability to explore complicated analytics queries on terabytes of information and get response in seconds, even milliseconds. But for our team, it wasn't enough. So we work hard on new capabilities to enrich and to accelerate the queries even more. Let's look into the table. Materialized view is a view of table aggregation that runs periodically to materialize the source table into the view. The view is always retrieve up-to-date information, which combine the materialized part with fresh data that were added since the last update cycle. It enhances performance with cost reduction. Common use case is for aggregation query that requires high performance. Also, since the retention policy of the view is separated from the source, you can save the source data for a shorter period than the aggregation one and save storage and cost. Let's look into a demo.
Yes, I actually know that many customers are looking for materialized views. They are waiting for the performance improvement, and I think it would be excellent for those use cases.
So it's great update because it's very intuitive and has high performance optimization for our customers. So do you remember the online event data, the table that we have just created in the previous demo? We can see the table's data, which was structured data that we ingested a few minutes ago. Now, I am going to create materialized view, which is the aggregated view on this data that will create a distinct count of the host per container image. The data is created, it's going forward, so every new data that will be ingested to the source table also will be materialized to the aggregation view. Let's see a short sample, and now let's run the view, and we get a result that is a combination of the fresh data together with the materialized data. Just for example, if I don't care about the fresh data, I can live with the small latency, and I do care about the high performance, I can run the materialized view function, which retrieves only the materialized part of the information. As I mentioned before, the retention policy of the table and the source table doesn't have to be the same, but by default they get the same value. I can change it by running alter merge command, and now I have a separate retention policy for the aggregation view. And I can also ingest the information and run and see the results. So now our customer can use it. It's open and available to all our customers.
Excellent. Perfect.
Partitioning. Azure Data Explorer divide data extents per create time. But in some cases where there is a table which often filters an aggregation on other column than create time, you can decide to define partitioning on that column. Currently, partitioning supports two types of column, string and datetime with high cardinality. All Azure Data Explorer queries execute and retrieve fresh data. In some cases, when a user needs super fast response time, can get some latency and run the exact same query few times in a row, for example in dashboards, query result caching is the technical capability to enable that. The user can run query and define the max age of his results, and whenever the same exact query will be executed under the max age, the cached result will be retrieved with very high response time. Gabi, would you like to tell us a little bit about Geospatial?
Yes, perfect. Thank you, Tzvia. So Geospatial helps users in connecting time series data with geospatial location data. Azure Data Explorer allows connecting time series data with polygon reference data to provide risk analysis, agriculture and mobility solutions, and more. And now let's move into a very interesting topic, visualizations. Great, so dashboards and reports are a key space for data exploration in Azure Data Explorer clusters. And as such, we make sure to provide extensive options for connecting to the leading BI services. Today, Azure Data Explorer has native connector support for Power BI, Grafana, and Redash. Furthermore, we support ODBC and JDBC connectors, which allow connecting to most of the visualizations offering out there. ADX Dashboards was launched 3 months ago and is now in public preview. This native dashboard solution is targeting the big data space, which requires focus on scale and performance. A significant advantage of ADX Dashboards is the deep integration with Cousteau Web Explorer client that serves data exploration using KQL queries. Today you can start with a query in the query area and create a dashboard visual off of that query, or vice versa, further explore dashboard visual data by exposing the query behind it and moving to KQL. In addition, there is a strong bias for query performance optimization, leveraging KQL strength to improve dashboard rendering time and expedite slice and dice scenarios. Okay, so I'll show you a quick demo using Azure Data Explorer dashboards, starting with Cousteau Web Explorer query area. So here I have a query, a simple query that filters for a specific time range and then shows data from GitHub events, which is public data. So I'm running this query in the Web Explorer. I see that I get the results, 1.5 million records, and then I go and share that query with my own dashboard. I have the experience in Cousteau Web Explorer to open that screen, name the query. I'll call it login since I'm counting the number of logins in that GitHub data. I'll name my data source and I'll add it to an existing dashboard. I'll add it to the GitHub dashboard. I'll also check this checkbox in order to view the dashboard immediately after I'm adding the query. So you see that I've added the query and now I'm taken into my dashboard. So at this point I can go and edit that query in order to enhance the visual and make it more appealing and more suitable for the dashboard that I'm using here. So I go into the edit card screen, and here basically I'm going to use parameters in order to unlock the filtering capabilities. Great, so I'm adding a time filter using the built-in time picker. So in order to build that time filter, I'm using the column and I'm using the between operator and starting with the start time parameter and ending with the end time parameter. I'll add another filter to this query and allow filtering by event type. So I'm selecting type. I'll put in it the type parameter, which is called _event type, which was defined by me earlier. And in addition, I'll support the select all option, which is a very prominent option with dashboards, and use the isEmpty operator in order to use that. So again, using the event type parameter, and then I can run the query, and you see that I'm getting results, and you've seen that 2 of my filters here were enabled. The reason that they were enabled was since I used the parameters that are underlying in those filters. So now I can go and change, for example, push event and select create event, add create event, and you see that the result here is changing according to this filter. Now in order to complete this visual, I'll go to the visual formatting piece. I'll change the table into a stat, which is more reasonable for that kind of presentation, and I can apply the change. I can go and drag this tile and put it somewhere here. I can decrease it a little bit just to make it fit the space that I have here. And that's it. I have a new visual in my dashboard, and from this point I can add more dashboards, or I can go and search other queries that I can leverage for this specific scenario. Tzvia, what do you think about our ADX dashboards?
It seems amazing that now we have a way to actually display big data, terabytes of information in a very nice UI.
Excellent. So now let's shift gears and move to new developments in our Grafana plugin. ADX plugin for Grafana was developed together with the Grafana team 2 years ago, and we're constantly adding new capabilities to it according to customer feedback. A month ago, a major update was released that adds Query Builder support to the existing plugin. Query Builder allows every user, even if he is not familiar with KQL, to create his own panels using simple drop-down controls to select values, grouping, and filters without one line of code or query. Later, if needed, it is always possible to move to raw mode and use the generated query as a basis for further enhancements of the panels. Let me quickly show you a demo on my hosted Grafana instance demo. So first, you start with a new panel. Once opening the new panel, you go and select the data source you want to use. I'll be using demo 11 data source, which contains the GitHub data I just showed you. I'll be using GitHub database, and I'll select events from livestream table as the source of my queries. First, I'll start with a filter. I'll filter by event type. So I'm typing here, starting to type, and I get the drop-down to auto-populate for me. And here again, I'm starting to type the value that I want to filter according to, and that would be push events. Next, I'll add the column that I'm going to use for presenting the values. So I'll select IDs and I'll aggregate the values according to count. Last thing, I'll add a grouping for that data, and that would be by the time column. So I'll use the created add column, which contains the date-time information. Great, so now I run the query and you see the visual that I'm getting. I've did it very simply without any code or query language, so that's very easy. Down here you can see the generated query. So if you want to go and tweak that query later in order to do some optimization that are not available through the query builder, you can always go and select edit KQL and come here to the raw mode and change anything you'd like. For example, I want to put here 7 days for binning the data, so I'm getting here different results, and I can do anything here that I'd like to do in order to optimize and adjust my visual for my dashboard needs. I can always go back to the builder by selecting switch to the builder, but I need to keep in mind that the builder doesn't give me the full flexibility of the query language. So if I do that, I need to understand that I will get part of the query that the builder supports. So that's the new capability from Grafana, and you're welcome to try it out. It's actually something that customers have been asking for a very long time. What do you think, Tzvia, about the query builder?
Definitely, I'm going to use it, and I know that many of our customers are waiting for that.
Moving forward to Power BI. Power BI is a leading general-purpose BI solution out there today. It has extensive user base and many use cases it supports. We're constantly working with Power BI team to add more big data capabilities and optimizations to provide the kind of scalable and performant experience users expect in this space. Recently, Power BI team released dynamic M query parameters, which is a big improvement to accommodate big data scenarios that customers were asking for a long time. Prior to dynamic M query parameters, the only way to set query parameter values was through Power BI Desktop. The new feature allows queries to be updated dynamically based on filter or slicer selections made by report readers in consumption view. This feature would be supported for direct query sources that are M-based, which for now means only ADX. This feature is critical for query performance optimization, since it allows injecting filters at the beginning of the query generated by Power BI, which is key in reducing query time, mainly in cases filters cannot be propagated effectively by ADX engine. Another long-time requested capability, mainly by enterprise customers, is PBI VNet support. It is planned to be released soon, and it will allow creating Power BI dashboards and reports for data hosted in VNet injected clusters. This takes us to the next topic, which is enterprise readiness. Row-level security is a relatively new capability that allows the database admin to assign row-level security policy on specific tables and control access to such tables or limit the visibility of specific properties. This serves as an advanced security feature to limit access of users to only their data while managing the data in one repository. Let's jump quickly to a demo. I'll use sales table, which contains generated sales data, to showcase this feature. Okay, so I'll start by counting the number of rows in sales. As you can see, it contains 10,000 rows. I'll show you some examples of the table. So it contains the timestamp of a specific deal. It has the customer name, the amount paid, the credit card number, and the salesperson email. So in order to use row-level security first, I need to create a function that will define the row-level relationship. So I'll be using this function to specify that only users from the AD group called custodev LT will be able to show the credit card details. In addition, I've defined here that each person accessing the table will use his own identity, and he will see only rows that are using his own identity as the seller email. So once I've created this function, I can move forward, and I need to assign the row-level security policy. I do that by running the policy command on the table itself, sales RLS, and now I'm all set. Access to this table is blocked for anybody according to the restrictions I've presented below, and the only person that can go and change those definitions and remove the policy or modify it are the database admins. So for example, again, I'm running the sales count command in order to see how many rows I see as a user, and now you can see that I see only 179 rows that are attributed to me as a salesperson. And if I go and want to see the rows themselves, you can see here that I only see rows that the seller email, and in addition you see that there is masking over the credit card number, and I can see only the last 4 digits. And that's basically what the row-level security function provided me. And now, in order to show you how the function works, I'm going to modify the AD group that controls the credit card details. So now the AD group would be custopm, which I'm a member of. So once I'm running that new query, basically it should provide me access to the credit card details. So I'll run the sales table take 10 commands in order to see the rows that I'm entitled to, and now you can see that I see the full credit card number without any obfuscation. So that's exactly the kind of limitation that we want database admins to be able to impose on their own databases. So moving forward to our next enterprise ready feature, which is VNet. We've added manual support for creating private links and injecting ADX cluster into those VNets. The main benefit is that enabling customer injection to the VNet does not require peering. Now we'll move to some news on the Azure Data Ecosystem collaboration front. We're integrating Azure Data Explorer with Azure Synapse to allow ADX users leverage Azure Synapse Studio Unified Workspace to run Spark jobs on their data in ADX, orchestrate jobs, and more. Azure Data Share GA allows sharing big data at scale with Azure Data Share in Place sharing for Azure Data Explorer without having to manage any pipelines. This feature is now GA. Azure Data Explorer native extension in Azure Data Studio is now available in preview. This native KQL support brings another modern data experience to Azure Data Studio, a cross-platform client for Windows, Mac OS, and Linux. Users can now connect and browse their Azure Data Explorer clusters and databases, write and run KQL queries, as well as author notebooks with Custo kernel or Python kernel. So that's the news on our ecosystem front. Now, Tzvia, please take us to new generation compute and let us know where do we stand with that.
Gabi, it sounds so interesting. I'm pretty sure that our customers are anxious to use all these amazing capabilities. Another 2 major new options were added also to ADX Compute in the last couple of weeks. First, combination of Azure Data Explorer v3 engine and the new AMD SKUs will give you the best price-performance ratio on Azure Data Platform. Second, as Gabi mentioned, VNet and Private Link are already supported. But starting from now, Azure Data Explorer can be defined in isolated compute on the cloud for isolated and highly secured architecture. And now we are getting to the very exciting moment, Azure Data Explorer quiz. The first participant, or the first viewer actually, that will answer all questions correctly will get Surface Duo. So please enter this link and the QR code and let's go! The name of the winner will be announced at the beginning of each breakout session, so you are more than welcome to join us to the breakout sessions. Another new announcement is the Ask Me Anything sessions. You ask, we answered. Every last Wednesday of the month to meet with the product group and to ask any type of question on ingestion, on performance, on any type of upcoming features, whatever you would like to ask, we will be there to answer. Next, we are going to meet with Ariel Pisetzky, the VP IT and Cyber of Taboola, and he will share with us his experience with Azure Data Explorer. Thank you, Gabi, for the great updates, and thank you for sharing your time with us, and see you in the breakout sessions.
Thanks everyone, and stay safe.
Welcome, Ariel.
Hi, my name is Ariel, and I'm the VP IT of Taboola. Taboola is the content discovery platform. We provide you with those moments of next, when you're online, reading, and you're looking for that next article that you are interested in. We are that engine that provides over 4 billion pages a day, that provides over 30 billion recommendations a day, personalized for you. We do this for 1.4 billion unique users a month, providing services in 34 different languages and powering billions of moments of next. To be exact, 1.5 billion clicks every month. We do this on approximately 4 billion web pages a day. We do this with about 30 billion recommendations a day, and we ingest 35 billion lines of logs. That's over 45 terabytes of data coming in every day. So how did we do this before Azure Data Explorer? Before Azure Data Explorer, logs were sent to a cloud storage. And then on that cloud storage, we would have a Logstash integration and pull that data locally to an Elastic cluster on-prem. This cluster, a large on-prem Elastic cluster, was managed locally by my team, the Site Reliability Engineering. And we looked at how we could do something better, something that would require less effort on our side, and how we can impact the business in a meaningful way. So we decided to look at Azure Data Explorer. We get a phone call from Microsoft, and we look into this new technology called Azure Data Explorer that we want to bring in and understand how it can impact our business. So a simple integration, point and click, all you need to do is enable the service and push your logs into that cluster. Once you have it up and running, all of the connectivity options are open for you. You have the direct query via the GUI. You have an API integration. We, for us, use also a Grafana integration, and there are multiple other integration options. The operational simplicity of just using a cloud service as this vast log crunching engine allowed us to impact the business immediately. Within 1 week of the system in place, we had multiple developers and multiple teams working on the system, creating relevant insights out of this vast amount of logs. So if we took just the first week of our working with Azure Data Explorer, although it has a new query language for us, this is not ANSI SQL, this is the Cousteau query language. Although this is a new approach in log transfers, and at the time there was no existing customer. We were one of the at least first customers on the platform. Within 1 week, we had magic. Everyone that touched the system wanted more. The developers fell in love. The service that we provided moved from an on-prem log crunching service to this amazing, easy to use, simple to query service called Azure Data Explorer. Now let's talk a bit about the kind of things that we do with our system. So here's a wonderful example. We have a simple query here for 48 hours. So if you think of the vast amounts of data that come in in 48 hours, we're talking about 90 terabytes of data, we're talking about multiple billions of lines of logs. We can, within seconds, immediately see a representation of our traffic. Now, this is a very simple count. So we took a count of every minute, created a line, parsed a few kind of parameters here, and within seconds we have answers. We can now dig deeper. We can now find additional ways to interact with the system and find more meaningful insights that we can use to improve our product. Here is another example. We wanted to look at our performance. So you see here the 99 percentile of our real user monitoring. So this isn't synthetic monitoring. This is actual data from our system showing how long it took us to serve each user. And you can see here that we serve 50% of the users within tens of milliseconds. And then all the way up to the 99th percentile, where it takes us longer to serve our customers. Here's another great example and another representation. You see here an A/B test of a control and variant, where we have two versions out in the wild, and we would like to see the different behavior of those two versions. Again, this is real user monitoring. So what we see here is a stacked column rendered in real time with URL parsing, 7 seconds, and we have here about 1 billion lines of logs that are just on the fly transformed into a visual representation of an A/B test happening within our system. So let's talk about the simplicity of using Azure Data Explorer. We parse billions of lines of logs fast. Now I'm talking about tens of billions of lines of logs in different queries, and I'll show you that in a moment. I'm talking about a simple querying language. So I get this question from time to time, wait, it's not ANSI SQL? No, but it's simple. Everyone can use it because it is that intuitive. It points you to the issue. When you use Azure Data Explorer, you really get a sense of a path towards the problem that you're trying to solve. And another kind of wonderful quirk that we love to use in the system is writing our own functions that we allow an easy way to share information between the different engineers in my team. So I can write this really elaborate query, and I can then create a function out of it to provide it to other engineers so that they can easily integrate it into whatever they would like to use. Here is an example of getting creative. So what we see here is an anomaly detection real-time query running on 13 billion lines of logs and doing it in 2.7 seconds. So it is not only running through all the lines of logs, it is parsing the URLs, and it is building a list of the different options and creating an anomaly detection on that vast amount of data. So we have here, in this kind of flat line, you can see the negative and the positive, which are different types of anomalies that we detect within the flow of traffic that represent something to us in our use case. In this case that we see here, these are the versions that come out. And obviously when a version comes out, you have some type of anomaly because you have a change. This is another great example of what we do with Azure Data Explorer. Here, with the API, we integrated our own dashboard to fit a lot of different queries in one small space that allows us to create an effective dashboard. So, bringing it all together, Azure Data Explorer helps us make sense of billions of lines of log, helps us create coherency, create dashboards, and create a better product for you. Thank you for listening.
Most of Microsoft services use Azure Data Explorer. Although the subject is huge, the interface is accessible, warm, and intuitive. Not only does ADX work, it works really fast, and it stays highly performant regardless of scale. It provides amazing interactive capabilities to the teams, which allow them to do a whole lot more.
Hi, I'm Yves Sharon, the CTO of Zoom, an Israeli public traded company in Canada. The two things I like the most in the Azure Data Explorer. First is the ability to ingest and analyze lots of data very fast, and second is the simplicity and convenience of using the query language in the IDE.
We were able to build a complex solution rapidly and grow our business while transforming the architecture into ADX. And we were doing that with a single data engineer and with almost zero downtime. With Azure Data Explorer, we have great performance and are confident that our new data solution can handle very large data volumes without incurring any performance costs.
So it turns out that there's a tremendous power in the flexibility in data ingestion and extracting and loading of our pre-normalized semantic data streams, and the ability to use the power of KQL, for instance, as well as the broad available inbuilt functions and extension points, makes it a very unique offering out there. And the performance and options to scale worldwide are very impressive. So for us, the use of Azure Data Explorer has a tremendous value for us.
It's easy for non-data scientists to get insight into the data and use their own tools to work with the data without having to set up a Jupyter notebook or other data science-related tools. With PlayFab and Azure, we have a much better understanding of each individual player through every touch point that helps us make better decisions, improve game experiences, and grow the audience of our games.
Hey there, I'm Thomas Zeiser, and I'm Cloud Delivery and Operations Product Owner at Siemens Healthineers. I love how we leverage Cousteau data modeling capabilities to create analytics dashboards with Power BI.
Hi, I'm Philipp. I'm Operations Engineer at Siemens Healthineers. What I love most about the Cousteau query language is its data analytics capabilities. Especially with the Python plugin activated, there is no challenge too big for Cousteau.
Hi, I'm Henri Benoit. I'm working as a software development lead at Siemens Healthineers in Germany. I love how Cousteau allows me to perform interactive data exploration with smart drill down in order to detect and analyze issues.
Hi there, I'm Emilian Ertel. I work as a senior key expert in the operation team at Siemens Healthineers in Germany. I love the powerful and intuitive features of the Cousteau query language. Thank you, guys.
Our clients love the ability to easily, seamlessly, and securely connect to their data and then build their own custom reports and analytics. They are able to instantaneously refresh data into their Excel sheet within a few seconds, whereas previously they would have to wait for a report refresh cycle, which could take 15 to 30 minutes.
2 years ago, we started using Microsoft's Azure Data Explorer to efficiently combine time series data and other data of our production plants and facilities in 350 locations globally. We look forward to continue the successful collaboration with Microsoft.
Azure Data Explorer has been instrumental in making this happen. It's helped us provide a much better marketing service.
We have been very committed to our development center. I mean, you see all the products we build, whether it's Sentinel or advanced threat protection products, the Data Explorer, some of the fantastic breakthrough technologies that we're very proud of as a company.
Yes, let's rock. Okay. My name is Avner Aaroni, and I'm a principal program manager on the Cousteau team. With me is Alexander Slutsky, a principal engineering manager of the Cousteau engine team, and Evgeny Rizik, who is a partner developer of the Cousteau engine. Today we are announcing the public preview of Cousteau Engine v3, the new and improved version of the database engine that is powering the Azure Data Explorer service. I am very happy to be here and to talk about the public preview of the new Cousteau engine, which delivers unmatched performance for the telemetry and logs big data scenarios. With this new engine and the new AMD SKUs we are offering starting from today, we expect to significantly reduce the cost of Azure Data Explorer service and to make it even more economic and the cheapest offering in the industry. Starting from today, you can create new clusters that are using the new engine. Later, we are going to enable the migration of existing clusters to the new engine. We are planning to have the GA date for February 1st, 2021, and during the preview, we will not charge cluster, which is running with the new engine, the ADX markup. The charges for the markup will be resumed in April 1st, 2021. Alex, can you tell me more about the new engine and what is different from the prior engine?
Yes, Sammi, thank you. So the engine V3 started actually 3 years ago when we looked on the success of the existing technology and wanted to improve it even more. So we wanted to achieve at least 10x performance improvements and be able to run more concurrent queries on the existing hardware configurations, be better on the existing hardware configuration. Now, we knew that we have a very tough competition ahead of us, and by that I mean ourselves, Cousteau Engine V2. So seriously, we come a very long way of our technology. By that time, Microsoft was extensively using our service, either for log telemetry solutions or as a platform. So many of the security and log analytics products were already built on top of Cousteau. So what we did, we took all the use cases and scenarios that we knew from major scenarios, and we looked on the petabytes of data that we indexed and were available for scanning. We looked on different query patterns that are being used. We compiled all this knowledge into something new and came up with the idea that we need a substantial change, a foundational change of the Cousteau engine. The results, I'm very happy to tell you, were outstanding. So we achieved the magnitude level improvements in the query performance. We reduced the cost significantly, and I hope that I will be able to show it in a very short demo that I'm going to show right now and demonstrate it to you all this, because I think that demo will speak much more about how it will actually it looks, rather than me sitting here and hand waving in front of you.
Great, let's see the demo then.
Cool, so I'm moving to the demo. We are talking about a data set that is 100 terabyte and consists of 403 billion records, as you can see here. The cluster that we are using is 9 LV1 machines. This is the machine standard SKUs that are available in Azure, and they are coming with large disks, and they are able to host this data due to the high compression that we have. If we look on the sample records of this data, you can see that this data is one table, huge table, with many different columns. It has timestamp, source and defined machines, and the clusters. It has some free text as a message, and also sometimes a properties field, which is a dynamic field consisting of various and semi-structured data set. This table is quite common and typical for the telemetry scenarios, and that's why it will be interesting to see how it perform over different queries, different scenarios with Engine V2 and Engine V3. On this side of the screen, you can see the Engine V2 working on top of this data, and on this side is a different cluster of also 9 machines with the same hardware configuration attached to the same data set. The data set is same up to the same record. So a first example of a very common scenario is looking on a time frame of window which is quite large, and also looking for some kind of event. For this example, we look on the level which is a warning and some specific message type. So we're actually filtering on timestamp, on the level, and the message. So let's see how the engine compares in terms of performance. Running on Engine V2, we can see that it finishes in about 3.6 seconds, and the time consumed here, the total CPU time consumed by all machine cores, is 381 seconds. The same query, if I run it on Engine V3, we will immediately see also by human eyes that it completes much faster. It completes only in 400 milliseconds, and the total CPU time is about 20 times faster, so it's only 21 seconds, which is quite impressive looking on this large data set. The other common scenario will be looking on aggregation by several dimensions and finding the top contributing value for this kind of scenario. In this case, we're aggregating by level and by component, and we're looking the count by these two elements. So this query in Engine V3 takes about 2.5 seconds and consuming 230 total CPU time, and for Engine V3 it completes much faster, only in 270 milliseconds, and also about 20 times faster, only in 11 seconds of total CPU time. And this shows the high aggregation without any massive filtering. So it's literally aggregating billions of data in just few milliseconds. That's quite amazing performance. Now let's move to something more complicated. I will going to run a pretty complex query which looks on 3 days of this data, which is billions of records, filtering on specific source. I'm going to deconstruct the message with some specific identity, finding a table name, extracting it from this command, and I'm going to join, self-join with a different event, trying to find out how many different correlations, how many different sequences happen in this case. What I'm going to do additionally, I'm going to find what is the most contributor per each format and per each table. So what we have here, we have massive join, we have filtering, we have deconstruction and parsing of unstructured text. So let's see how the two engines perform here. Running this on engine V2, the query completes in 578 milliseconds, which is quite impressive. So let's see if the engine V3 can beat it. Now let's run it here, and we see that actually the time is also here in this complex query shortened by about a factor of 4 or 3, but also in total CPU time. What that means that actually not just query completing much faster, but they also allow you spend less CPU time on the same query, increasing the performance and concurrency both at the same time. So as you've seen in this demo, we are able to complete the same workload using the new engine in times faster, sometimes up to 20 or 30 times faster. And that means that not only the queries complete faster and get you the desired results in a shorter time, but it also invests less CPU, meaning that you increase in concurrency for the very same workload on the very same hardware. And that makes that's exactly what makes the engine V3 superior for many different workloads and scenarios. Okay, Avner, how was the demo?
The demo was great. Thank you so much, Alex. So I'll move over to Evgeny. Evgeny, how did you make this magic happen?
Sure, let's move to the technical details. As some of you may know, all data ingested into Cousteau table is partitioned into shards. Shards are horizontal slices of the table. Usually each shard contains a few million records. Each shard is encoded and indexed independently, which allows us to achieve a linear scale in ingestion throughput. Shards are spread evenly across the cluster nodes, and they are cached on those nodes, both on local SSD and in memory. Then our query planner and the engine take care to prepare and execute a highly distributed and parallel query that benefits from this shard distribution and caching. The new version of the engine focuses on optimizing the bottom part of the distributed query. Now, this is the part of the query that runs against each data shard and performs the heavy lifting. The nice speedup you've seen in Alex's demo is due to two major changes we introduced in version 3 of the engine. First is new, much improved shard storage format, and the second is the redesign of the low-level shard query engine. So let me describe both in more detail. Shard format is a compressed column store with special attention to unstructured, which is text, and semi-structured JSON data types. It incorporates most of the features one would expect to find in the modern column store. Special encoding for and compression for numeric types and timestamps, dictionary encoding for low cardinality text fields, layout optimized for analytical queries. Shard storage is augmented with the redesigned indexes for all the fields, inverted index for text and JSON data, range index for numerical data. The new index is granular, and for many queries it allows evaluating parts of the query based entirely on the index without scanning the data. The query layer is tightly coupled to the shard storage, and we took an approach here very different from the previous implementation. So what we did is the entire shard query is just-in-time compiled into highly efficient machine code. This results in a very fast, very efficient fused query evaluation logic. So the query compilation is guided by the data statistics that we gather from all the shards that we have. It is tailored to the specifics of the column encoding.
So Evgeny, if you did all of this new storage engine and storage format, does it mean that the new engine is not compatible with the old engine?
It's a great question, Avner. No, the switch is transparent, or mostly transparent. So once the switch to the new engine is made, new data is ingested into a new storage. Historic data remains in the legacy format, and both engines run side by side, and all queries work the same.
Thank you, Evgeny. That was really great.
It's my pleasure, but what about Alex?
Alex was also great.
Thank you, Avner. Thank you again.
Now that we went through the engine v3 with Alex and Evgeny, and you know more about it and looked at the benchmark, I encourage everyone to go to the Azure portal and to give it a try and experience the amazing performance yourself. Thank you so much, Alex. Thank you, Evgeny. As for the continuing agenda, we are now going to take 10 minutes break, and afterwards we are going to have 6 different breakout sessions that we encourage you to join. Until the session starts, you are welcome to take the quiz, and the first one that answers correctly all the questions will win the new amazing Surface Duo device. The winner will be announced in the beginning of each breakout session. Good luck, and thank you all for joining our session.
Thank you.
Thank you, guys.
Hi, my name is Vlad Rozanovich. I'm the Corporate Vice President at AMD, responsible for the data center segment and data center customer part of the organization. And it's a pleasure to be here with you to talk a little bit about the AMD and Microsoft relationship, specifically as it pertains to Azure Data Explorer. Microsoft and AMD have had a long-standing relationship for many, many years, collaboration around things like client products and OS development, extensions of 64-bit technology to the marketplace. But what we've seen also is that in 2017, when AMD introduced our EPYC portfolio of products, Microsoft was the first to actually introduce Azure-based VMs on our EPYC architecture. And then in 2019, we've seen a massive expansion of the number of offerings and the number of positions of products that Microsoft Azure has brought to the marketplace, including general purpose and high performance compute, and specialized, which I'll talk about here in a few minutes. I've also seen massive collaboration around things like Azure HCI certifications on AMD EPYC from some of the OEMs, and most recently, collaboration around Windows Server 2019. When I think about the go-forward path in 2020 and where we are today, what I see today is that the expansion of worldwide availability of those AMD EPYC offerings has continued to expand. And we've also seen expansion within the internal properties, where organizations like Office Online have started taking advantage of some of the architecture that AMD is bringing to the market. And talking about that architecture, this is really, the AMD EPYC portfolio is something that we introduced with use cases like Azure Data Explorer in mind. When we think about the massive amount of CPU cores, the memory bandwidth, and the I/O bandwidth that we put into our EPYC CPU, this was for the use cases of what Azure Data Explorer is looking for in the marketplace. When you think about the massive amount of streaming information that Azure is looking to analyze in a real-time basis in a streaming capability, there's no other CPU architecture that can handle ADX workloads like AMD. And this is really the seeing Azure Data Explorer move forward with AMD EPYC as the core product to ADX. This is really what we see as kind of the culmination of why we designed this product to begin with. And that product is being used in multiple areas within the Azure environment, not just on high performance compute and GPU visualization type products, but also for storage optimized and general purpose. And this is the area where we've got offerings of EPYC that fit all of these use cases. And when I think about things like GPU visualization, this is one where it's a AMD CPU plus AMD GPU offering on NVV4, bringing the highest levels of GPU visualization in a virtualized environment to Azure. And then when I think about the progress that Azure has made putting our products within the HPC instances, HPV2, you are delivering world-class on-prem performance in the cloud. And that's one of the things that we're proud of with the collaboration with Microsoft. In addition to all of the general purpose offerings that are bringing the best price performance use cases to the marketplace. And so when I think about why did Azure Data Explorer choose AMD EPYC as the engine to power these virtual machines, what we've seen is that it really comes down to a few things. In this new world of COVID-19, where everybody's looking for best price performance, what we're offering to the market is the lowest cost possible to deliver the highest opportunity of performance. And when we think about that performance level, what we have seen is that Azure is getting about 30 to 50% better performance at the same costs. And this is really something that is going to resonate with a lot of customers. And so when I think about the product offering that AMD has brought to Microsoft and that Azure has now introduced with ADX to the marketplace, I think about the hardware innovation from AMD and what the Azure Compute team has done, partnered with the database software innovations of Azure Data Explorer with that Custo Engine version 3. And what you really get is this affordable, powerful analytic tool that can handle huge amounts of volume and a streaming capability to analyze that telemetry data And that's something that is really delivering value to end users. And so I wanted to say thanks. Thank you to Microsoft. Thank you for the customers that will be using the Azure Data Explorer engine on AMD EPYC, and really appreciate the support. Thank you.
Welcome to the Innovation Center of Bühler here in Switzerland. And we want to talk about Bühler Insights and how we use Azure Data Explorer. I'm Cedric.
And I'm Samuel. And Cedric, why don't you tell us what Bühler is doing?
Bühler is a machine manufacturer and solution provider for the food processing industry and automation industry. Every day, billions of people come into contact with things that have been produced on Bühler machines. Be it like your coffee that you have in the morning, the rice you eat at lunch, or having your beer after work. There is a high probability that these have been produced on machines engineered by Bühler. With our solution portfolio, we are covering a large part of food processing in the value chain for grain, for example. We are providing solutions for processing grain into flour, which being used later for dough or pasta or wafers. Because of the large portfolio of solutions and the footprint we have in the world, we are uniquely positioned to have a powerful level for a better world. With climate change more and more impacting our daily lives, we set ourselves a clear measurable target. We want to reduce energy consumption, waste or water by 50% of all our equipment.
So, in order to achieve these goals in our customers' facilities, Bühler is providing several different digital services, all under the umbrella of myBühler. And you can see there's one central part which brings all of these services together. This is data. And this is exactly where Bühler Insights comes in. So, what is Bühler Insights? Bühler Insights is a near real-time monitoring and analytical solution. It takes care about collecting the data at customer facilities, this can be machines or whole plants, and sending it back to a centralized, always-on, highly distributable, secure data store. And on top of this data store, then we provide several different API and services to enable our customer to gain actionable insights on top of this data. So Cedric, why don't you tell us a bit more about the foundation, the heart of Bühler Insights?
Here we see an overview of the Bühler Insights solution architecture. Bühler Insights is made of a collection of APIs and services around Azure Data Explorer. And one key part is the ingestion pipeline, where we collect data from our plant and machines of our customers. Basically, we have the ingestion pipeline which subscribes to the Azure IoT Hub and do the deduplication of all our messages, maybe of resilience reason if the platform has an outage. We do the message validation, decompression of all the data, and policy check if a device is allowed to send the data to us. Afterwards, we enrich our message properties of the Event Hub with tenant information, so Azure Data Explorer can dispatch those messages into the databases. Every tenant has its own database with the same table and schema. So the message flow is based on those message properties. Afterwards, we ingested the data in our raw table of a tenant-specific database. We optimize the data structure through update policies to make the query faster from our services. Currently, we ingesting 86 million records per day. Another area is our Bühler Insights APIs and apps and portal built on Azure Data Explorer. So there we can provide context-aware applications, for example, real-time dashboards, where we can do on-demand calculation against the telemetry data, and we provide a huge widget library, for example, bar charts and time series charts. We also have the possibility to enrich the telemetry data with our master data from the ERP to give more context of the data. We also provide domain-specific visualization, for example, silo monitoring or yield calculation. Samuel, can you give us a short demo how we calculate a yield of a plant?
Sure. Here you can see a real-time dashboard of a milling plant where you can see throughput and yield. The throughput is a good example which is on demand calculated, and the yield is something we calculate in the background with batch processing. And you can see that I can navigate through the data and which can give me insights to the data or to the customer. If I want to see what's going on that time area, I can just switch the time area on demand, and all calculated values are updated directly and instantly for whatever time range I want to have it. So this is really valuable for our customer, and they can gain direct insights to their data.
Another area is basically our rule and calculation engines, where we can produce new insights for our customers with cyclic and batch calculations. So we provide the capabilities to do sampling and sliding windows on existing data and ingesting that data again, like the ingestion pipeline, into the event hub, where Custo does the dispatching of that data. This data can then be visualized again on our dashboards. We provide, for example, customer-specific KPIs. We can do downtime analysis of plants and machines, overall efficiency of a plant. We can even do process optimization and do predictive maintenance of our machines. The other area is where we provide a rule engine to do, based on data and events, create alerts and do notification with email, SMS and push notification. Maybe we can see such a calculation in live, Samuel.
For sure. So on this dashboard we see actual data from a finer. This is a chocolate machine, and we can see several different KPIs which are calculated over a week. This could be like overall equipment efficiency or just the availability of that machine. And I can just choose again the time range from a week to a day, but something is strange on this dashboard. I can see the availability is 800%, which is kind of strange. So I have two options now. Either I fix it by myself, or I can send it back to the data science team and say, hey, please fix this issue. So I can, for example, just jump over to Custo Data Explorer and use normal KQL to analyze what's going on with this query. And I can see that, oh, there is maybe someone put the wrong factor in this calculation. So let's try to fix that, and I can see, now the values are getting better actually. And I can then go back to Bühler Insights and go to the calculation engine where these formulas actually stored, and just use the same language as I used in the Custo Explorer, and just change it back the factor and save it. Go back to the dashboard, let's see, and it shows 88%, it's already fixed. So this is really easy for everyone because there's just one language, and you can directly fix any error or change formulas on demand, whatever you need.
Another feature we provide is how we can give access to our data science team to do data analytics and exploration. So therefore, we introduced the follower cluster, where all databases from the production system are mirrored to the follower cluster. So when we create a new database on the production cluster, it's automatically created on the follower clusters, and our data science team can do the exploration there. They can use their Python application or Jupyter notebooks to do further analysis and machine learning on existing data, and even provide train models and do other performance and load testing. Another option what we can do is continuous export, where we export all the data to Azure Data Lake, and which can then be included as external table and queried via KQL. Maybe you can give us a small demonstration how a data scientist accesses this data.
Sure. For that, I as a data scientist want to use the tool what I actually used to work with, right? So I'm using here such a Jupyter notebook, and I use a KQL Magic, so a Magic built from Microsoft to use that to directly connect to the cluster, to the data. And I can also use directly this KQL inside this dashboard, and you can see I can directly plot the data. And now I can go a step forward and say, okay, I don't want to just visualize the data. I also want to do some machine learning built on top of it. And for that, I can use built-in feature, like the machine learning built-in KQL. Like I've done here, you can see the orange part is the input, and the blue part is the predicted time series I get out of it, of this availability. And then another part, when I want to go a step forward, I can just load the data into a data frame, and I can use standard machine learning libraries. And here what I've done is I trained an sklearn supervised machine learning model to predict the future of this availability time series. And you can see the red is the input again, and the blue is the output. And with that, it's pretty easy for me with my tools to work with the data from the Azure Data Explorer data.
Sounds very interesting. So to summarize what benefits we've got from using Azure Data Explorer, it's basically one language for everyone. So our customers, our developers, our operations team, and the data science team use one language to querying and building new solution on top of existing data in Azure Data Explorer. It's a fully managed solution where we basically don't need to train our IT department how to operate the cluster and how to do scaling on top of it. So there we can basically provide an easy option for the operation to scale it up with different SKUs and also scale it horizontally by adding nodes to an existing cluster. We also have the capabilities to provide our data science team access to the follower cluster, where we don't influence the production system when we do extensive queries on this existing data. And last but not least, access management is done via Azure Active Directory, where we have fine-grained control how we give permission to our employees, to the data science team, to our customers, and also to our applications. I hope we could provide you some insights how we use Data Explorer.
Yeah, thank you very much, Cedric. Thank you very much, you listening to us this evening, and we wish you a lot of fun on this event. And let's go back to the Microsoft team.
There is a viral feeling in the air. Our power is in the democratization of data. Knowledge is accessible for everyone. On the way to a good and successful event, many bumps can happen. Talking fast.
Of the existing technology, and wanted to improve it even more.
Laughing endlessly. Not looking at the camera.
From the product groups.
Sending family materials. Confusing endless words. Disappointed. And trying again and again. Sweating endlessly in the heat.
Comparing,
stick to each other and separate. But in the end, the result that justifies the efforts.
Thank you. Good luck.
Thank you.
Thanks everyone.
Thank you guys.